bisection method and regular falsy method. First we discuss theoretical concept of a bisection method, then one example by bisection method of a algebraic equation and one example of a transcendental equation by bisection method. Then we discuss about the regular falsy methods. So as in a previous discuss some basic concept of how we find the solution of algebraic and transcendental equation by the bracketing methods. So as we know that bisection method is one of the bracketing method. So there is a need to find out bracket means upper end and lower end, means lower bracket and upper bracket. Now what is the bisection method? First we give the detail of a bisection method. Bisection method. So as in a previous lecture we discussed about this one. Okay, this one is under the category of a bisection method. Now how we find the solution of any algebraic or transcendental equation by the bisection method? Suppose there is a function y equal fx, and as we know that this one is a bracketing method. So first of all we find a bracket, means one point where the value of the function is a positive and another point where the value of the function is negative. Suppose these points are, this one is a and this one is a value of a function f of a. So f of a here less than 0, and suppose this one is a b, then here f of b is a greater than c. So what is the necessary condition to apply a bisection method? F of a into f of b must be less than c. So from here, if f of a is less than 0 and f of b is greater than 0, then obviously f of a into f of b is less than c. Now to find out the next point, suppose here we find a c equal what? C equal a plus b by 2. Then we examine the nature of a function at point C. What is the value of a function at point C? So what are the possibilities? Possibilities are either f of c equal to 0 or f of c is greater than 0 or f of c is less than c. So there are three possibilities. So if f of c equal to 0, then what we conclude? We conclude that c is a root of y equal fx. Now suppose f of c is greater than 0, then according to the necessary condition, at one point the value of the function is a positive, at another point the value of the function is negative. For sake of simplicity, suppose here the value of a c lie here. The value of a c lie here. Then obviously, what is the value of a function here? This one is f of c. F of c, obviously, this one in this quadrant, what is the value of a function? Value of the function is less than 0. Now, root lie between c and b. Why the root lie between c and b? Because there is one negative or one point where the value of the function is a negative and one point where the value of the function is positive. So what's happened here? Here we try to synchronize, try to minimize our search space. Initially, what is the search space? Minus infinite to infinite. Then we confine our search space from A to B. Now we confine our search space from C to V. So if we closely observe this one, this algorithm, so here if we denote this one not by the C, we denote this one by the x0 here, because here we denote the x0, then this one is a x0 is a less than 0, x0, and similarly here we write a x0 and x0. So now how we find the value of x1? In this case, if f of x0 is a less than 0, this possibility, x1 equal x0 plus b by 2, x1 equal x0 plus b by 2. If we closely observe x0 and x1, what will happen here? Here we interchange the value of a from x0. This means we change the value of such value where the value of the function is a negative from the such values where again if the value of the function is negative. So we interchange the values. If at this point the value of the function is a negative, then we interchange such previous value at which point, at that point the value of the function is negative. So here we replace a by the x0. So in a next iteration, suppose here the x1 lies between x0 and xb, x0 and b, and suppose this one is a what? x1. Then obviously at this point, what is the value of a function? This one is a first quadrant. In a first quadrant, what is the value of a function? Value of a function f of x1 is a greater than c. So what's happened here? Here at this point, in this iteration, at this point the value of the function is positive. So in the next iteration, we replace by the positive value. What is the meaning of positive value? The value at which the value of the function is greater than 0. So in the next iteration we interchange, we replace b by the x1. So x2 equal what? x2 equal x0 plus x1 by 2. So in a similar manner, here we find the what? If we find the x2, and similarly we find the x3, x4 up to xn. So xn. Now question is when we stop this procedure. When we stop this procedure, so means what is the number of iteration? What is the number of iteration? Means I will perform this procedure 10 times, 20 times, 30 times, 40 times. How many times? So how we decide this one? This one can be decided on the basis of what is the desired level of accuracy. What is the meaning of this one? Desired level of accuracy. Desired level of accuracy means either we try to find out the solution correct up to 1 decimal places, 1 decimal places, or 2 decimal places, 2 decimal places, correct up to 1 decimal places, correct up to 2 decimal places, correct up to 3 decimal places, and so on. So here we define a value EPS epsilon, this one. So this one is a 10 to power minus 1 if we try to find out the solution correct up to 1 decimal places, and this one equal to 10 to power minus 2 if we find the value correct up to if we try to find out the solution correct up to 2 decimal places. So similarly 10 to power minus 3, 10 to power minus 4 means what is the desired level of accuracy? Means 1 decimal places, 2 decimal places, 3 decimal places, and 4 decimal places. So if the difference of two successive iterative values is less than this EPS, then we stop our iterative procedure. Now, for example, suppose x1 equal x0 equal alpha 1, x1 equal alpha 2, similarly x5 equal alpha 5 and xn equal alpha n, xn plus 1 equal alpha n plus 1. So, if you find the positive difference of this one, means xn plus 1 minus xn are this one less than EPS. Less than EPS, then we stop our iterative procedure from n plus 1. So, if we conclude this one, if the positive difference of a two successive iteration, value of iteration is less than EPS, whatever we decide, either correct to a one decimal basis, means 10 to the power minus 1, 10 to the power minus 2, 10 to the power minus 3, this one is less than EPS, then we stop our iterative procedure. Now, if we try to find out an expression in term of a what? In term of a EPS and initial values, means A and B. So, what is the meaning of this one? If we have A where the value of the function is positive or negative, f of A is less than 0. B where f of B is greater than 0. Like in this case, f of A is less than 0, f of B is greater than 0. Now, suppose we define a central value. Suppose here we consider EPS, whatever the value of EPS, maybe the 10 to the power minus 10 to the power minus 2, 10 to the power minus 3, whatever the value. Now, if we closely observe this one, this procedure of a bisection method, this one is a A and this one is a B. How we find the value of x0? We find the value of x0 equal A plus B by 2. B by 2. So, x0 equal A plus B by 2. What is the meaning of this one? This one is suppose the length of A to B. A to B is a what? A to B is suppose this one is a what? This one is a L. This one is a L. So, what is the length in a second iterative procedure? The length from x0 to b means this one is a 50% portion, this one is a 50%. So, this length become what? This length become L by 2. And your next iteration, this length become what? This length become L by 4. L by 4. So, in a first iteration, the length become, initially length is a what? Length means difference between B and A. B and A, suppose this one is a L. So, in a second iteration, what is the length of a class interval where root where root exists is a L by 2. In a next iteration, what is the length? Length become L by 4. Now, if we denote L equal what? L equal B minus A. B minus A. B is a word where the value of the function is a positive. A where the value of the function is negative. So, in a first iteration, what will happen means in a first iteration the length become what? V minus A upon 2. In a first iteration. In a second iteration, the length become V minus A upon 4. You may also write this one equal what? b minus a upon 2 square. 2 square in a first iteration. This one is a length of a interval. This one in a second iteration. In a second iteration. Similarly, in a third iteration, this one becomes b minus a divided by 2 to the power 3. In a similar manner, in a nth iteration, the length of a class interval becomes b minus a upon 2 to the power n. Because here in the second iteration 2 to the power 2, in a third iteration 2 to the power 3. In a similar manner, there is an nth iteration, then this becomes 2 to the power n. Now, means this interval becomes closer to this one is a what? This one is our actual root. Suppose this one is our actual root. So, if the value of this one b minus a upon 2n, is less than what? Is less than EPS. Less than EPS. Then, what is the known values initially with us? A, where the value of the function is a negative, V, where the value of the function is a positive, and EPS is a what? The desired level of accuracy. Now, how we find the value of n? Very simple. Here we take a log. So this one is if we simplify this one become 2 to the power n. This one become 2 to the power n. 2 to the power n is greater than what? 2 to the power n EPS. This one is a b minus a upon epsilon. Taking log on both sides, this one n is greater than log of v minus a upon EPS epsilon divided by what? Divided by log 2. Divided by log 2. So, this expression basically, if we have a value of a and b, then n must be greater than log of a b minus a upon epsilon divided by log 2. You may also write this one in a more simplified form. N is greater than log of v minus a using the property of a log minus log EPS divided by what? Divided by log 2. So if we have a value of a, b and EPS, then we able to decide what is the value of a n, means what is the number of iterations required to find out a what? To find out desired root correct up to a desired level of accuracy. So to solve a numerical example, there is a 3 value, the requirement of a 3 values, means a value where the value of the function is a negative, another value where the value of the function is positive, and EPS means a desired level of accuracy. Then we perform number of iteration more than n time, and we calculate the n with the help of this expression. And how we interchange the values of a and b? In a starting, we describe how we interchange the values of a and b. Now we consider example of a bisection method. First we consider means how we solve an algebraic equation with the help of a bisection method. Then we take another example of a transcendental equation and try to solve with the help of a bisection method. Now, so I'm not going to erase this one because this one is going to use to find out the solution of any algebraic or transcendental equation. Now we try to solve this example of means suppose y equal fx equal x cube minus x minus 1, and we try to find out this one correct up to we try to find out the solution which is a correct up to 4 decimal places. 4 decimal places. Okay. So what is our first aim? First aim is to search the value of a and b. First we try to find out the values of a and b. So how we find the values of a and b? Suppose here we put x equal 0. So what is the value of f of 0? F of 0 equal what? Here we put the 0, then this one is a what? This one is a minus 1. So this one is a minus 1. If we put x equal to 1, then what is the value for f of 1? F of 1 is a what? F of 1 is a 1 minus 1. This one is again a minus 1. Now at x equal to 2, this one become f of 2. This one is if we put here 2, this one is 2 is 8 minus 2 minus 1. This one equal minus 2 minus 1 minus 3. This one is 5. So 5. Now we stop our search. Why we stop our search? Because here we able to find out a point where the value of the function is a negative and one another point where the value of the function is positive. Okay. So what is the value for a? A become what? A become 1 and b become what? B become 2. Because at 1 the value of the function is a negative and 2 the value of the function become positive. So according to the bisection algorithm, what is the value of x0? X0 equal a plus b by 2. A plus b by 2. So what is the value for this one? The value for this one is very simple. If we find this one, 1 plus 2 by 2, this one is a 1.5. 1.5. Now we try to find out the values of value of a function at f 1.5, means f of x0 equal what? F of 1.5, and this one equal 1.5 whole square whole cube minus 1.5 minus 1. So if we simplify this one, then what is the value for this one? The value for this one is a what? 0. Here we already noted down this one. This one is a what? 8750. 8750. 8750. This one is the value of f of x0. F of x0. Now, if we closely observe here, what will happen in the next iteration? Means x1, what will happen here? At x0, the value of the function is positive. So we interchange such value where the value of the, in a previous iteration, the value of the function is positive. So what will happen here in a previous iteration at b? At b, the value of the function is positive. So we interchange the value of b with x0. So what is the value for x1? x1 become a plus x0 divided by 2. a plus x0 divided by 2. So what is the value for a? Value for a is 1 and value for x0 is what? 1.5 divided by 2. This one equal 2.5 means 1.25. Now what is the value for function at x1? Means the f of 1.25. So value of the function at this point is what? This one is a 0.29 minus 0.2968. 2968. Now at x1, what is the value of the function? Value of the function is negative. So in our next iteration, we replace the value of our x1 from which values of a previous iteration, means either from a or x0. So at a, what is the value? Value is a negative. At x0, what is the value? Value is a positive. But at x1, the value is a negative. So we replace negative by the negative. So what is the value of x2 here? The value of x2 become what? x1 plus x0 divided by 2, means here we replace a by the x1. Why we replace a by the x1? Because at a, what is the value? At a, the value is negative. And at x1, what is the value? Value is also negative. So we interchange the values, where in a previous iteration there is a negative, and in this iteration, current iteration also this one is a negative, then we interchange the values, negative values from the negative one. So in this iteration, what is the value? x1 is a what? x1 is a 1.25 plus what is the x0? x0 is a 1.5. 1.5 divided by 2. This one is a 2.75 divided by 2, and this one is a what? This one equal 1.3750. So in this manner, we calculate x3, x4, x5, x6 and so on up to a desired level of accuracy. So here already we noted down the values for x0, x1, x2, x3, x4, x5, x6 up to x11 and x12, and the values of the function f of x0, f of x1, f of x2, f of x3. So now if we try to analyze this solution, corrected to a 1 decimal places, or 2 decimal places, or 3 decimal places, or 4 decimal places. So how we analyze this one? So in this example, what is the value of a? The value of a is 1, the value of b is 2. The value of a is 1, value of b is 2. Now suppose we try to find out root correct up to 1 decimal places. Then EPS is a what? 10 to power minus 1. 10 to power minus 1. Now if this one is a 10 to power minus 1, then n is a greater than what? Log b minus a means 2 minus 1 minus log 10 to power minus 1 divided by log 2. So this one equal to what? Log 1 minus, this one become plus 1 log 10 divided by log 2. If we write the values here, then n must be greater than, this one becomes 0, the value of log 1 becomes 0, the value of log 10 is a 1. So this becomes 1 upon, the value of log 2 is a what? 0.3010. So if we simplify this one, then what is the value for this one? If we simplify this one, then the value is a what? 3.321, and if we round off this one equivalent to the integer value, this one is the 4. So what is the meaning of this result? N must be greater than 4, means the number of iteration must be greater than 4 if we try to find out the root is correct up to a 1 decimal place. And we start from these two initial values, a equal to 1 and b equal to 2. Then n must be greater or equal to 4. So if we closely observe the solution, then here this one is the first iteration, this one is the second iteration, this one is the third iteration, this one is the fourth iteration. So n must be greater or equal to 4. So here up to a 4 iteration, if we closely observe this one, then you will see if the root is repeated up to a 1 decimal place. Means in x2 this one is a 1.3 something, in x3 means in a fourth iteration this one is a 1.3 something, means now if we try to find out the root correct up to a 1 decimal places, the value is what? 1.3. Now suppose we try to find out the root correct up to a 2 decimal places, then this become what? 10 to the power minus 2. Now if this become 10 to the power minus 2, then all other values same. This one is a 2, this one is a 2 time of this one is a 2 time of what? 2 divided by 3010 is a value of log 2. Now what is the value? Value is a 6.67 like this one, 6.6 and so on. Means if this one is equivalent to if we convert this one equal to integer value, this one must be this one means number of iteration cannot be now fractional value, means not be a real value. This one must be an integer value. So n must be greater or equal to 7. So this one is the first iteration, this one is the second iteration, this one is the third iteration, this one is the fourth iteration, this one is the fifth, this one is the sixth, this one is the seventh. So in a 7th iteration, if we observe this one, 6th and 7th iteration, you will see this one now root is repeated up to a 2 decimal place. So what is the meaning of this one? Meaning of this one is root is now correct up to a 2 decimal places is a what? 1.32. Now question is find the root correct up to a 4 decimal places. Similarly here we write 10 to the power minus 4, 10 to the power minus 4 and try to find out the value of n. Then whatever the values, accordingly we perform the number of iteration. Here we perform the number of iteration here x12, then be able to find out what? Be able to find out the root correct up to a 4 decimal place, 1.3247. So and vice versa, if we closely look the value of a function, the value of a function tends toward to the 0, tends toward to the 0, because as we approach to the root, exact root, the value of the function approaches to the 0. So this one is an example of algebraic equation how we solve with the help of a bisection method. So we find the values of a and b, we find the values of n, then we perform the number of iteration according to the algorithm and we find the solution of any algebraic or transcendental equation. Now we try to solve the numerical example of a bisection method, means with the help of a bisection method how we solve any transcendental equations. So first of all, we write example. We try to discuss how we solve the transcendental equation by the bisection method. Now, suppose here we consider y equal fx equal x minus cos x. This one is a transcendental equation. Why? Because there is an involvement of a special function cos x. So now how we solve with the help of a bisection method? Bisection method. Bisection method. Bisection method. Bisection method. So obviously this one is a what? This one is a transcendental equation. Transcendental equation. Why this one is a transcendental equation? Because there is an involvement of a special function. So what is the procedure? First of all, we find a value where the value of the function is a positive, another value where the value of the function is negative. So suppose x equal to 0. X equal to 0, then what is the value for f of 0? F of 0 equal what? 0 minus cos 0, cos 0, and obviously we know that the value of a cos 0 is a 1, so this one is a minus 1, this one is a negative sign. Now our next aim is to find out such values where the value of the function is positive. So at x equal to 1, if we write f of 1, this one is a what? 1 minus cos of 1. So what is the value for this one? Here already we noted down the value for this one is a 0 point plus 0.4597. Now we stop our search. Why we stop our search? Because we able to find out find a point where the value of the function is a negative and one another point where the value of the function is positive. Now what is the, so here we write what? A equal 0 where the value of the function is a negative, v equal 1 where the value of the function is positive. Now what is the first iteration? In a first iteration we find x0 equal, according to the algorithm of bisection method, a plus b by 2. x0 equal a plus b by 2. Now x0 equal a plus b by 2. So this one equal what? 0 plus 1 divided by 2. This one is a what? 0.5. Now what is the value of a function at f of x0? F of x0, f of 0.5. F of 0.5 means here we put 0.5 minus cos of 0.5. Cos of 0.5. So already we have calculated this value. The value for this one is a what? The value for this one is a minus 0.37. 0.37 like this one, 0.37758. 758. So what will happen in next iteration? At x0 the value of the function is a what? Value of a function is negative. So in a previous iteration at a, what is the value of a function? Value of a function is negative. So we replace a by the x0. Why? Because at a the value is a negative, also at x0 the value is a negative. So what is the value for x1? x1 is a x0 plus b by 2. So x0 is a what? x0 is a 0.5. 0.5 plus, what is the b? B is a 1 divided by 2. This one is a 1.5 divided by 2. This one is a 0.75. So in the next iteration, we find the value for what? We find the value for f of x1. So means the f of 0.75. So already we calculated the value for this one. The value for this one is a what? The value for this one is a plus 0.01831. So if the value for this one is a positive, so in the next iteration what will happen? At x0 the value is a negative, at b the value is positive. So we interchange the value for b by the x1. So in x2 what will happen? x0 plus x1 divided by 2. So in this way we calculate the values of x2, x3, x4, x5 up to xn. What is the meaning of xn? Means a desired level of accuracy. Here already we noted down what are the values of x0, x1, x2 and x3. Here only we noted down the value of 4 iteration. So up to a 4 iteration what will happen? So if we try to find out the accuracy, means a desired level of accuracy. Now again if we try to find out the solution correct up to a 1 decimal places, then what is the value of EPS? The value of EPS is what? 10 to power minus 1. So what is the value of n? N must be greater than what? Log V minus A minus log EPS and divided by what? Log 2. So this one equal to what? Log. What is the value of A and B here? The value of A and B is 0 and 1. Difference of these two is 1 minus log. What is the value for this one? 10 to power minus 1 divided by log 2. Now again the value for this one is a 0 minus 1. The value of a log 10 is a 1. So this one divided by log 2. This one is a 1 divided by 0.3010 and this one is a 3 point, means almost 3.32 like this one. So if the equivalent integer value is a what? This one is a 4. This one is a 4. So if we closely observe the solution, this one is a 0, this one is a 1, this one is a 0.5, this one is a 0.75, this one is a 0.625, 0.6875. So x0, x1, x2, x3. So up to 1 decimal places, what is the minimum number of iteration required? Minimum number of iteration is what? 4. So first iteration, second iteration, third iteration, fourth iteration. So here the root now repeated up to a 1 decimal places. Means now root is correct up to a 1 decimal places is the word 0.6. So one another things, if we see this formula, means n is greater than log b minus a minus log EPS divided by log 2. Log EPS means if 4 decimal places, 5 decimal places, if this one is a fix, EPS is a fix, log 2 is a constant value, then number of iteration depends on the difference of A and B. Difference of A and B. So as the difference of A and B is large, the value of n is large. Means n not directly related to the difference of B minus A, because now epsilon is a fix. You have already fixed that if we try to find out the root, which one is the correct up to a 4 decimal places. If this one is a fix, this one is a constant. So according to n, if this one vary, then this one also vary. So as the value of a log is the value of this difference is larger, then n is also larger. So what is our aim? Our aim is to find out such values of a and b whose difference is minimum. In this way, we able to minimize our number of iteration. So as a and b is far, then the number of iteration is large. If a and b is close, means we consider a is a 0.5 and b is a 1. So means 0.5 and 1, then in this case obviously n is less than 4 in case of 1 root is a character to 1 decimal places. So this one is an example how we solve the transcendental equation by the bisection method. Now next bracketing method is a what? Next bracketing method is a regular falsy method. So next we are going to discuss first theoretical concept of a regular falsy method, then we try to solve numerical example based on using the regular falsy